Math 2, Unit 5, Lesson 5, we're on page 298. We're talking about conditions for rhombuses, rectangles, and squares. So last time we talked about rhombuses and squares and rectangles. So now it's kind of like we're doing the converse of some of them, okay? So I would have out your highlighter so you can highlight some of this. But specifically here on this Theorem 53, it states that if the diagonals of a parallelogram are perpendicular, so diagonals are perpendicular, then the parallelogram is a rhombus. Okay, so this is going backwards. They're saying right now that if you have two perpendicular lines, the diagonals are perpendicular lines, then it is a rhombus. Okay? Theorem 54. Okay, if one diagonal of a parallelogram bisects a pair of opposite angles, so we're bisecting opposite angles, then it is a rhombus. So you'll notice here that it's bisecting the angles. If you have a figure that has angles that are bisected, the diagonals bisecting those angles, it is a rhombus. Okay, if the diagonals of a parallelogram are congruent, so diagonals are congruent, and what does congruent mean? The same. Then the parallelogram is a rectangle. So if you have two diagonals that are congruent, meaning they're equal, then that is a rectangle. Okay, and that was on page 299. Okay, moving on to page 300. Are we ready? Okay, and all that information is pretty much on your yellow cards as well. So on page 300, it says, can you conclude that the parallelogram is a rhombus, a rectangle, or a square, and explain? So I'm going to give you 30 seconds. Oh wait, Seth already has the answer. So what is number one? Okay, how do you know that it is a rhombus? Okay, so diagonal bisects a pair of angles. All right, number two, are we able to tell what that is? The answer is no, or not enough information, but we're just going to put no. Does anyone know why? Like, it's telling you that these, first of all parallelograms, their diagonals bisect. So on a rectangle, we know that the diagonals are congruent, but is it showing that these are congruent right now? No, because it's saying that this piece is equal to this, and this is equal to this, but in a rectangle, all of them are equal. Okay, so I'm going to put no, and then I'm going to put diagonals bisect, but this is true in all parallelograms. Okay, so all parallelograms have diagonals that bisect. Rectangles, though, all of the diagonals are what? The same or congruent. Therefore, we don't have enough information to call this one a rectangle. Okay, staying on page 300, I want you to do problem number 2. So it says, for what value of y is the parallelogram DEFG a rectangle? So in order for this to be a rectangle, what would we have to do? Good, you'd have to set each of those segments equal to each other. Once you get your answer, show me on your fingers. Good, 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 good. 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 Good, 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 good. Perfect. Okay, so the correct answer was 4. You should have written 5y plus 3 equals 7y minus 5. In order to solve this, I would subtract 5y. 3 equals 2y minus 5. I then add 5 to both sides. 8 equals 2y. And then last I divide by 2 to get y equals 4. Any questions? Okay, let's move on to page 301. So on page 301, it says, for what values of x is the figure the given special parallelogram? So what would need to be true about those two angles? They need to be the same. They need to be equal. So set them equal to each other and get the answer. And I'm going to just write on here that diagonals bisect angles. That's how I know that I can set those equal to each other. Yes, so you're finding x. Exactly. That works. Yeah, good. That works. Perfect. Good. Yeah, that works. You can show me like the tens place and the ones place. Good. Good. I don't get that. This is what it should be, or this. Okay, the correct answer is 12. Good. Okay, so we would subtract 2x to both sides. So I have 39 equals 4x minus 9. What would I do next? Add 9. 39 plus 9 makes what? 48 equals 4x, and we divide by 4 to get x equals 12. Okay, next one, rectangle. Good, good. Good. Good, good. 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 That times 2 is the correct answer. Good. 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 No, I'm not sure, Nate. Good. 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 Yes, Rich. Okay, so the correct answer, good, is 10. Okay? And so in a rectangle, what do we know about rectangles and diagonals? Diagonals are congruent. They are the same. So they gave us the two, good, lengths of the diagonals. And so we have 4x minus 7 equals 2x plus 13. I can subtract 2x from both sides. At the same time, I'm going to go ahead and add 7 to both sides. So I get 2x equals 20. Divide by 2 and x equals 10. Okay. All right, so lesson check, page 302. It says, can you conclude that the parallelogram is a rhombus, rectangle, or square, and explain why? So, on number 6, what is it and how do you know? Okay, rectangle is correct, but how? Perfect. Diagonals are congruent is what I was looking for. Okay, number 7. Okay, rhombus is correct, but why? How do we know? Diagonals are perpendicular. If you don't know, that means perpendicular. Are we good? Anybody need this still up? Okay, still on the same page. We're now looking at a rhombus, or I think we're on the same page, page 302. Yeah. Okay, so it tells you for what values of x does it make it this figure. So how can this be a rhombus? What can we do to make it that it's a rhombus? The sides have to be congruent. So I'm going to put congruent sides. So you are going to end up setting these equal, and then you can show me your answers. Good. Good, good, good. 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 Yes. Perfect. Good. 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 No. Okay, yes. Good. No, we're still doing, okay, we're still on 8. 2 is the correct answer for 8. Okay, so you should have put 8x minus 1 equals 3x plus 9. Shh. Subtract 3x. Add 1. And we get 5x equals 10. Divide by 5 and x equals 2. Now, what has to be true in order for number 9 to be a rectangle? Diagonals are congruent. Okay, so also, they also bisect, right? Okay, so if you set these equal to 0, what's your or set not set equal to 0 to each other? Good, 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 good. Good. Perfect. Good. Oh. Tricking me. Okay, the correct answer is 3. So we have 3x minus 5 equals x plus 1. Add 5 to both sides. Subtract x. 2x equals 6. X equals 3. Do we have any questions? Okay. Number 10, this is now on page 303. Okay. What figures? So we have, what figures is this true for? Rhombus, which means it's also a square. I want to bring something to your attention. Look at your yellow card here real quick. Okay, so looking at your yellow card. Okay. Remember how a square includes everything that's a rhombus and everything that's a rectangle. So if something's a rectangle, it's also a square. If something's a rhombus, it's also a square because it includes all of those things. So that's why on A, it's a rhombus, but it's also, thank you, a square. Okay, so on B, diagonals are congruent. Where are diagonals congruent? Rectangle, which means it's also a square. Okay, keep going to C and on to the next page too. Here. Okay, so what was C? Rhombus is correct, which means it's also a square. Okay. Still on page 303. Diagonals bisect each other. It's all three. It's a rectangle, rhombus, and square. Last one. Diagonals are perpendicular. Very good. Rhombus, square. Okay. Do we have any questions?